Okay, so really, once again, we're going to be graphing, which is going to be easy. Remember, in this class, we really, for the most part, we're just plotting points. I am going to teach it a certain way, though, to make it a little easier, to graph a little quicker. Honestly, I feel like this is the easiest way to do it. Instead of learning tricks to do it this way, it's really nice. Okay, so we're going to be, first of all, graphing shifted quadratics that have the form y equals a times x minus h squared plus k, a quadratic of that form. Because then that's in shifted form, and we know shifting for all functions works the same. So let's first take a look at the parent function of y equals x squared. Notice that the parent function means no shifts. Like, look, it's the most basic function. There's no shift left and right. There's no shift up and down. Your a is a 1. So, like, just plug in some values. Now, think about it. For a quadratic, we can plug in anything. Like, we can plug in, you need to do at least, like, 5 or 6 points. So, let's plug in -2, -1, 0, 1, and 2. So, -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Quadratics are symmetric, so notice these points are symmetric, right? Like, they're symmetric over the axis of symmetry. So, let's plot those points. 0, 0. Over 1 up 1, over -1 up 1, over 2 up 4, over -2 up 4. Do you guys see what I mean by it's symmetric? Okay, so obviously, right here is my vertex at 0, 0. Vertex is the highest or lowest point of our parabola. So our vertex is at, for the parent function is at 0, 0, which is where the axis of symmetry lies. Axis of symmetry just means where it's symmetric over. So we literally are just stamping it across the axis of symmetry and they're the same. Pretty easy stuff. Now what we're going to do is we're going to take this parent function point, these are the points for the parent function, and we're going to start shifting it around. Like literally picture yourself taking these points and shifting it right 5 units. Wouldn't you just take this point and add 5 to it? Add 5 to all of your x values then, right? That didn't change our y. But then now let's shift it up and down. Let's say I shifted up 2 units. We'd take all of our all of our points and go up 2. So we're taking your y values and adding 2 to those. So we're literally going to take our parent function points and we're just going to write down new points. That's going to be the easiest way. So what would the shift be for all functions? Can anyone remember what's the shift for this? Like left and right, up and down, what? Left and right, good. That's our shift, left and right. We go opposite of the sign. This would be our right, like you were saying. And then this is our up and down, and the sign stays the same, so this would be up, K. And then this is a stretch or compression, and that will just stretch it out. Like stretching will be, it'll get larger quicker, and compressing it, it'll get larger slower. So it's vertical stretch, like a rubber band stretched up, or a compression pushing it down. Now a negative in front of A will take and reflect our points over the x-axis. So that would just take, look right here, if I reflect it over the x-axis, do you see how it changes all of our y values? So you just times your y values by -1, everyone. Isn't that what flips them? It doesn't change your x's though, does it? A reflection over the x-axis, like picture this coming down here. You just times it by -1. So up here at 4, it'd be it down at -4. So a reflection over the x-axis would just look like that. Okay, awesome. So what we're going to do is take our parent function points every time, and we're going to have, here they are. Parent function is for x squared, and here are those points that we have for the parent function. So now what we're going to do is perform the indicated operation. I don't want to make you graph both. If you did, then that's extra work. You could, then it's easy, but just write down the parent function points. Don't actually put it on the chart. Does that make sense, everyone? What I'm saying? Now what's the shift here? Inwards. Up 3. So that's a y shift, everybody. Up 3 is going on the y-axis. So take all your y values and you're going to add 3 to them. Add 3, add 3, add 3, add 3, add 3. So our new y values are at 7, right? 7, 4, 3, 4, 7. It should be symmetric, right? So now you say -2. Up 7 units, okay, great. Over -1, up 4 units. Over 0, up 3 units. Over 1, up 4 units. Over 2, up 7 units. And then we would draw in our parabola. What's our vertex at? Okay, good. 0, 3, which makes sense. Look, it used to be at 0, 0, but now it's up 3 units, right, everybody? So there's our vertex. This is the highest or lowest point. And this one, it's a minimum, a low. And my axis of symmetry is at x equals 0. Because it's symmetric over that x value, that line. Everybody good? Pretty easy, right? So what was my first step? Writing down the parent function points, which is right here. I've already got them written down, but you're going to have to do that. Writing them down. So you'd say the parent function for x squared is x squared, obviously. So then we're going down 2 units. Down 2 units, so you'll subtract 2, subtract 2, subtract 2, subtract 2, subtract 2. So now you have 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2 is negative 2. 1, and then it's just symmetric, right? So this will be negative 1, and this will be, what did I mess up on? 4 minus 2 is 2. It's just a 2 right there. Okay. So then you would just plot your points. So you're going negative 2 up 2, over negative 1 down 1, over 0 down 2, and then it's symmetric from there, so it's pretty easy to see. So let's say that you were like, well, I need to plot, because if we need to be pretty accurate, like you need to plot as many points that can fit on the graph accurately. So like what would our next point be? Well, if you don't know, couldn't you just plug in the value? Like say when I plug in 3, what's 3? So 3 squared is 9, but then we're subtracting 2, so that would have been 7. So over 3 up 7 units. So now since it has symmetry, can't I just go, okay, over 1, 2, 3, over 1, 2, 3, like that? Right, everybody? You guys see how this is working? Okay, where's my vertex? Without even looking at the graph, we should be able to see it. We'll shift it down 2, so it'd be at 0, negative 2, our vertex, right? It used to be at 0, 0. So our axis of symmetry right here is on x equals 0 again. Okay, pretty easy stuff, as you can see. Okay, let's do, I don't think we need any shifts up and down. Let's do a shift left and right. So this one you would say in words, what? Yep, right 2 units. So now from there, can anyone tell me what my vertex would be without us even having to graph it? Yep, over 2 of 0, right? Because it used to be a 0, 0, and now we're going right 2, so it'll be over 2 of 0. There's our vertex. That's our highest point. Or lowest point, depending. Now, so right 2, that would take all your x values and add 2 to them. So my new x's are negative 2 plus 2 is 0, right? 0, 1, 2, 3, 4. Those are our new values, and then our y's didn't change. 4, 1, 0, 1, 4. So those are our points. Over 0, up 4 units, check. Over 1 up 1 unit, check. Over 2 up 0, there's our vertex. Over 3 up 1, and then from there it's really easy once again because we have symmetry. So across the axis of symmetry. But once again, over 4 up 4. There's my axis of symmetry right there. Pretty easy. Okay, let's do one. I don't think you need to see another one just by itself. Let's do one with both shifts. Okay, so this one has a shift of left. Nope, it's not left, is it? What is it? Right 1. Okay, so right 1. Up 4. So what you'll do is go to your parent function points, which came from x squared. I'm creating them, writing down my parent function points. I've just done it to save time already. They won't be written for you. You guys get what I'm doing. So then from there you'd say, okay, so we got to go right 1. That's an x shift. So we're going to add 1 to all of our x's. And then we're going up 4. So we're going to add 4 to all of our y's. And then write down your new points. And then you're just plotting points. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Then 4 plus 4 is 8. 1 plus 4 is 5. 0 plus 4 is 4. Then it would be the same pattern, right? 5, 8. Is it symmetry? Then you're just plotting points. Over negative 1 up 8, check. Over 0 up 5, check. Over 1 up 4, done. Over 2 up 5, done. Over 3 up 8, and done. So my vertex is at, right there, isn't it? Over 1 up 4, 1, 4, which makes sense. Because look, let's be able to find the vertex without even having a graph. 1, 4, which makes sense, right? If that's what the shift is, that's what our vertex would now be at. because it used to be at 0, 0. Okay, awesome. Okay, so now with this one, we have an A value that's not a 1. That is a vertical. Vertical is a Y value thing. So this changes your Y values. It's a vertical's up and down, a vertical stretch or compression. So right here, this would be a compression of your Y values. So compression of a half. So what you're going to do is you're going to take your Y values and you're going to times them by a half. Yes. And that'll be your Y's you change, because it doesn't change your X's, it just changes how quick or how slow it goes up or down. But that doesn't change your X's. So let's take and rewrite our Y values. So 4 times a half, that's 4 divided by 2, which is 2, right? Decimals are kind of nice to graph, to be honest. So 1 times a half is 0.5. 0 times a half is 0. Then 1 times a half is 0.5. 4 times a half is 2. So now we're going over -2, and we're going up only 2 units, over -1, up only a half a unit, over 0, 0, over 1, up a half a unit, over 2, up 2 units. So it's compressed. Now, once again, I don't have enough points plotted to graph this accurately, so if I plug in 3, I get 9, but then I got to times that by 0.5, so wouldn't that be 3.5? No, it wouldn't. That would be not 3.5, 4.5. So that would be 4.5. So we're going over 3 up 1, 2, 3, 4.5. That's good enough. So then what can I know? This one at -3 will be up that same amount, won't it? So look, it's compressed. It's squished, essentially. But it all works out if you just perform it to your parent function points. Okay, let's put that. Oh, so what would my vertex still be at? 0, 0, because there was no shift left and right, no shift up and down. Okay, awesome. Okay, looking at this one has a -2. So it's a stretch of 2 and a reflection. Now that's both a Y value thing. So let's just hit 2 birds with 1 stone, and you times all your Y values by -2. It will take care of it. Yeah, because it's to both Y's, so let's just do both at the same time. So then 4 times -2 is -8. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. 4 times -2 is -8. So then we're going -2, -8. -1, -2. 0, 0. 1, -2. And then 2, -8. So it's stretched out vertically and it's reflected. There was no shift left and right, no shift up and down, so our vertex would still be at 0, 0. Okay, let's do one with all of the shifts. Oh, I don't think we need to do one of this caliber. Oh, actually, yeah, we do, actually. Okay, look at this one, because there's I didn't see this negative here. So in words, we would say that's a reflection over X. Reflect over X. Then after that, it's left 1. This is important to see, and then down 3. Down 3 units. Can anyone tell me my vertex without graphing it? -1, -3, right? -1, -3. It won't matter if it's reflected or not. So -1, -3, but we do know that it's going to be a frowny face, don't we? Because of the negative in front, that's what flips it. So this is going to be a maximum. This vertex at -1, -3 will be a maximum value since it's upside down. Okay, awesome, but now let's just perform the shifts. So first of all, a reflection over the X is a Y value shift. So notice there's 2 Y's, Y shifts. We have to times our Y values by -1 and go down 3. So what comes first, multiplication or subtraction? This is important. Multiplication, you've got to multiply before you subtract 3. So you're going to times all your Y values by -1. And then after that, you're going to subtract 3. Then our X's, we're going left 1, so we'll subtract 1. So then write down very carefully your new XY points, and it's really easy with parabolas to catch if you've done something wrong, because we're so familiar. There should be perfect U shapes. So if you have a weird point off in space, you know you've done something wrong. -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. Okay, we've taken care of all of our x's. 4 times by negative 1 is negative 4. Negative 4 minus 3 is negative 7. So then 1 times negative 1 is negative 1. Negative 1 minus 3 is negative 4, isn't it? Then we have 1 times, oh, we already did that. 0 times negative 1 is 0 minus 3. Now, from there, wasn't this our axis of symmetry? Our vertex, essentially? If that's our vertex, that's our axis of symmetry. So then after that, it will follow the same pattern. So this will be negative 4 and then negative 7. Or you could just keep going by calculating. Then you're just plotting points. So negative 3, negative 7. Over negative 2, negative 4. Check. Over negative 1, negative 3, check. Over 0, negative 4. Over 1, negative 7. And then there's our upside down parabola. And done. Everyone, do you see why this is a maximum? Because it's flipped upside down, making it a high point, not a low point of the graph. Okay. Just our y values. It didn't change our x's. If we take and reflect something over a y-axis, it didn't change your x's, it just flipped your y values. So we only did y. Okay, I won't go through and graph this. Okay, so write the function in shifted form and then graph it. So we'd have to use completing the square. Do you remember how completing the square puts it in this form? Puts it in this form from a few lessons ago. Completing the square puts it in this form, people. It just does. Okay, so we first have to write the function in shifted form. So what do? We set it equal to 0, so we have this. X squared plus 4x plus 3 equals 0. Good, way to remember, get the constant on the other side. So we have x squared plus 4x equals negative 3. Then what's the formula? Good, b over 2 squared, so that would be 4 over 2 squared, which is 2 squared, which is 4. So you're going to add 4 to both sides. Then you rewrite your problem, if you can remember. We have x squared plus 4x plus 4 equals 1. Now from there, you factor this side. We could use our trick. Isn't this positive 2? Before we squared it. So it will factor to be x plus 2 squared equals 1. Now from there, we need to get it back into y equals form. So bring 1 back over now. Bring 1 back over because it wasn't equal to 0. It's just equal to y. So subtract 1. So we have x plus 2 squared minus 1 equals 0. So there's our function. So now we just graph it. You'd say inwards. Okay, so understand we haven't changed anything. This is standard form. This is vertex form. So it allows us to see graphing it easier. So you'd say inwards, you'd say left 2, down 1. So then from here, this is what you would do, because once again, you won't have your parent function points written down. You're going to go, okay, my parent function points come from x squared. I'm going to plug in negative 2, negative 1, 0, 1, and 2. Negative 2 squared is 4, negative 1 squared is 1, 0 squared 0, 1, 4. Those are my parent function points. Then you're going left 2. So you'll take and say that's an x shift. So minus 2 from all your x's. And then down 1. So subtract 1. And then plot your point. Pretty easy, right? What would my vertex be? Negative 2, negative 1, right? Everybody, is it a maximum vertex? Because they're going to ask you this on the homework, or a minimum? Yeah, it's a min because it's a smiley face, right? It's a positive in front. A positive in front, so it's a smiley face. So you're right, our vertex is a minimum value, a low point. Good. I don't think you guys need to see me do any more x, y points. I think you get the picture with that. Do you want to do one more? Remember with the 2 in front, it's a little bit harder to complete the square. Do you want to do one more like that? Okay, awesome. Let's do that. So you first, it says write the function in standard form, in shifted form, and then graph it. So first of all, we set it equal to 0. Negative 2 x squared plus 4x plus 1 equals 0. Subtract 1 over. Negative 2, what am I doing? Negative 2x squared plus 4x equals negative 1. Factor out a 2 because you can't complete the square unless we have just a 2 in the front. Factor out a negative 2. So then left is x squared and then, okay, minus 2x equals -1. My next step is to get rid of that, right? Divide by -2. So then we have x squared minus 2x equals 1/2. So then from there, we're going to complete the square. So you'll do -2 divided by 2 squared, which is -1 squared, which is 1. So we'll add 1 to both sides. Okay, this is going to turn out really good. So we have x squared minus 2x plus 1 equals 1 plus 1/2. If you've got a common denominator, 3/2, right? 3/2. So you're going to watch me do something really interesting here in a minute. So then from here, what does it factor to be? X minus 1 squared, everybody. What if you didn't know? Just do it the good old-fashioned way, right? Okay. X minus 1 squared equals 3/2. Now, how many of you like to graph fractions? Not me. So it'll work out. Can't we times by 2 to both sides? Mathematically, isn't it the exact same? If I leave it or if I times both sides by 2? Yeah, so let's do that. Let's times both sides by 2 so we don't have to deal with fractions. Times by 2, times by 2. So now it divides out. So now we just have a 2 and x minus 1 squared equals 3. Now we're not dealing with fractions. So what would I do now? Subtract 3 over. 2x minus 1 squared minus 3 equals 0. So now inward you would say, okay, stretch of 2, write 1 down 3. So with your xy points, your parent function would be -2, 4. It's coming from x squared if you can remember. -1, 1, 0, 0, 1, 1, 2, 4. So wouldn't I do stretch of 2? That would be a y value thing. So you take your y values, you'll times them by 2. Then you're shifting down 3, so then you'll subtract 3. And then write 1, so to our x's we'll add 1. And there's your new point. Sweet. Hey. Alright, so that is the end of the lesson. So for today. Not too bad. We have a lot of time left.